Welcome to EduCasts, home of EduCasters. In the world of education, there is a frustration that every teacher and student knows all too well. It's that feeling when you spend weeks covering a topic. The students nod along, they ace the quiz on Friday, but by the time Monday rolls around, the information has seemingly vanished into thin air. It went in one ear and out the other. We often blame this on a lack of studying or attention, but if we look at it through the lens of educational psychology, the problem isn't usually effort. It's connection. This specific struggle, the difference between memorizing facts for a test and actually understanding them for life, is the heartbeat of David Ausubel's meaningful learning theory. David Ausubel, an American psychologist who made his mark in the 1960s, didn't care much for the trendy discovery learning methods of his time. While everyone else was hyping up the idea that students should figure everything out on their own, Ausubel stood his ground. He argued that teachers could just tell students information, reception learning, and it could still be deeply effective, provided one thing: the new information had to hook onto something the learner already knew. His entire philosophy boils down to one famous quote from the preface of his 1968 book: "The most important single factor influencing learning is what the learner already knows. Ascertain this and teach him accordingly." It sounds simple, almost like common sense. But when you really unpack what Ausubel meant, it provides a sophisticated blueprint for how the human brain organizes ideas, how we retain knowledge, and why rote memorization is the enemy of true education. We are going to break down the mechanics of meaningful learning, explore the cognitive structures that make it possible, and figure out how to apply this in a real classroom without getting bogged down in ivory tower theory. The core conflict: rote versus meaningful learning. To understand Ausubel, you first have to understand the distinction he drew between rote learning and meaningful learning. He viewed these not necessarily as binary opposites, but as points on a continuum. Rote learning is what happens when you memorize a phone number, a list of nonsense syllables, or the periodic table without knowing what an element actually is. It is arbitrary. There is no logical connection between the new information and what is already sitting in your brain. You are essentially pasting a sticky note on a wall. It's there for a moment, but the glue is weak, and eventually it falls off. In schools, we see this when students engage in verbatim memorization. They can parrot back the definition of photosynthesis, but if you ask them to explain how a plant grows in the dark, they hit a wall. Meaningful learning, on the other hand, is relational. It happens when new information is related to relevant concepts that already exist in a learner's cognitive structure. It's not arbitrary, it's substantive. When a student learns about the American Civil War, meaningful learning occurs if they can connect it to their prior understanding of conflict, economics, or slavery. The new info doesn't just sit on top, it integrates. It changes the way the student sees the previous information, and the previous information gives the new data a place to live. Ausubel argued that for meaningful learning to occur, 3 specific conditions have to be met. You can't just hope for it. You have to set the stage. 1. The material itself must have logical meaningfulness. You can't meaningfully learn nonsense. If I try to teach you a list of random passwords, you have no choice but to use rote memory. The content must be relatable to human ideas. 2. The learner must have relevant prior knowledge. This is the anchor. If I try to teach you about quantum entanglement, but you don't have a basic grasp of physics or atoms, my explanation will bounce right off. You need a concept in your head to subsume, absorb the new idea. 3. The learner must have a meaningful learning set. This is the mindset. The student must choose to relate the new info to what they know. If a student decides, "I'm just going to memorize this to pass the test," meaningful learning won't happen, even if the teacher does everything right. The cognitive structure, your mental filing cabinet. Ausubel was obsessed with the idea of cognitive structure. In plain English, this is just the organization of knowledge in your mind. Imagine your brain is a massive, highly organized filing cabinet or a library. You don't just throw books in a pile on the floor. You categorize them. According to Ausubel, our cognitive structure is organized hierarchically. We have broad, inclusive concepts at the top, and as we go down, things get more specific and detailed. For example, at the top, you might have the concept of living things. Under that, you have animals and plants. Under animals, you have mammals, then dogs, then golden retrievers. Learning is the process of slotting new information into this hierarchy. Ausubel called the existing concepts in your brain subsumers. A subsumer is like an anchor or a hook. It's an idea that is broad enough to hold on to new, more specific information. If a child already has a subsumer for birds, they know birds have wings, lay eggs, and fly, and you introduce them to a blue jay, the learning is easy. The blue jay fits perfectly under the bird umbrella. But if you introduce a penguin, the brain has to do a little more work because penguins don't fly. The structure has to adjust. This interaction between the new stuff and the old stuff is the magic of Ausubel's theory. The process of subsumption. This brings us to the most technical, yet most fascinating part of the theory, subsumption. This is the mechanism by which new material is integrated into the cognitive structure. Ausubel identified 4 main ways this happens. If you can wrap your head around these, you can teach almost anything. 1. Derivative subsumption. This is the most basic form of learning. It happens when the new information is just a specific example of a concept you already know. It poses no challenge to your worldview, it just adds detail. Example. Let's say you have a solid concept of mammals in your head. You know they have fur, give birth to live young, and are warm-blooded. You visit a zoo and see a lemur for the first time. The keeper tells you it's a mammal. Your brain goes, okay, got it. You simply file lemur under the existing folder, mammals. You didn't have to change your definition of mammal. You just derived a new example. It's quick, easy, and satisfying. 2. Correlative subsumption. This is where things get interesting. This happens when the new information is an extension or an elaboration of what you already know. But, and this is key, it forces you to slightly modify or expand your higher-level concept. Example, sticking with the bird concept. You think all birds fly. That's your rule. Then a teacher introduces the ostrich. It has feathers. It lays eggs. It has a beak. But it runs, it doesn't fly. To learn this meaningfully, you can't just file it under birds as you currently understand them. You have to tweak your bird subsumer. You have to qualify it. Birds are animals with feathers and beaks that usually fly, but some represent exceptions adapted for running. This is deeper learning because your mental model has actually become more sophisticated. 3. Superordinate learning. Usually we learn by going from the top down, general to specific. But sometimes we learn from the bottom up. Superordinate learning happens when you know a bunch of specific facts, and suddenly you learn a broad concept that ties them all together. It's that aha moment where you see the forest, not just the trees. Example, a child knows what a carrot is. They know what a potato is. They know what a turnip is. They treat them as separate food items. Then, a teacher introduces the concept of root vegetables. Suddenly, the child realizes these aren't just random items. They belong to a category. The new concept, root vegetable, is superordinate, higher up to the existing ideas. 4. Combinatorial learning. This is the trickiest one, but often the most powerful. This happens when the new idea doesn't neatly fit under an existing idea, subsumption, or above it, superordinate. Instead, it relates to your prior knowledge through analogy or parallel logic. The two ideas are on the same level, but they share common attributes. Example, learning about how electrical current flows in a circuit. For a novice, electricity is invisible and abstract. It's hard to grasp, but if the learner understands how a plumbing system works, water pressure, pipes, valves, they can use combinatorial learning. Voltage is like water pressure. The wire is like the pipe. The switch is like the valve. The plumbing knowledge doesn't contain the electrical knowledge, but it acts as a parallel structure that makes the new information make sense. The power of advanced organizers. So if prior knowledge is the key, What does a teacher do when students don't have the prior knowledge? Or what if they have the knowledge, but they don't realize it's relevant to the lesson? Enter Ausubel's most famous contribution to teaching strategies, the advance organizer. A lot of teachers get this wrong. They think an advance organizer is just an outline of the chapter or a list of objectives on the whiteboard. It is not. An outline just tells you what is coming. An advance organizer bridges the gap between what the learner already knows and what they need to know. It is a high-level, abstract introduction presented before the learning task. Its job is to activate the relevant subsumers in the student's brain. It primes the pump. There are two main types of advance organizers. 1. Expository organizers. These are used when the material is completely new to the learner. They provide a scaffold. For instance, if you are about to teach a class about the biology of a virus, and the students know nothing about it, you might start with a broad concept of parasitism, how one organism lives off another. Once they grasp the parasite concept, the organizer, you can introduce the virus as a specific, microscopic type of parasite. 2. Comparative organizers. These are used when the material is somewhat familiar, but you need to distinguish it from previous ideas to avoid confusion. For example, if you are teaching multiplication to students who already know addition, you don't need to start from scratch. You use a comparative organizer to show that multiplication is essentially repeated addition. You compare the new skill with the old skill to show similarities and differences. The advance organizer acts as a mental roadmap. It tells the student, hey, remember that file you have in your brain labeled conflict? Open that drawer because we are about to put the Civil War file inside it. Without that prompt, the student might be trying to file the Civil War under dates to memorize, which creates rote rather than meaningful learning. Progressive differentiation and integrative reconciliation. Ausubel didn't just stop at how we learn. He also gave advice on how we should organize the curriculum. He proposed two guiding principles that sound complicated but are actually very practical. The first is progressive differentiation. This is the idea that the most general and inclusive ideas should be presented first and then gradually differentiated in terms of detail and specificity. In a biology class, you shouldn't start with the Krebs cycle, a complex chemical reaction. You should start with the concept of energy, then respiration, then cellular respiration, and finally, the chemical details. You start with the big picture and zoom in. This mirrors the hierarchical structure of the brain. If you dive into the weeds too early, the students have no mental structure to hang the details on. The second principle is integrative reconciliation. This sounds like marriage counseling, but in education, it means making sure that new ideas are cross-referenced with old ideas. As you teach, you should constantly look back and point out connections. Remember how we looked at the French Revolution last month? Notice how the Russian Revolution has similar causes but a different outcome. This prevents compartmentalization, where students keep their knowledge in separate, sealed-off boxes. You want to force the cognitive structure to rearrange itself and build bridges between concepts.